Today we're talking about a pretty nasty threat that's been burrowing its way through the software supply chain, the Shai-Hulud malware campaign. And what's wild about this one is that it wasn't a one-and-done attack. This thing learned, adapted, and came back way stronger the second time. Here's how one security researcher's Monday started, with the realization that a major supply chain attack had returned, and was a whole lot worse. 1 minute, everything's normal. The next, a sophisticated worm is tunneling through their most critical systems. To understand how bad things got, we've got to rewind to where it all started. The first wave of attacks on the NPM ecosystem. And this wasn't random. It was a calculated opening move that set the stage for something much bigger. So what exactly is the Shai-Hulud worm? This malware is built to burrow deep into developer environments, and it has two main jobs. Steal valuable stuff, like API keys, tokens, secrets, all of it, and then use that access to automatically copy itself around the ecosystem. That last part is what makes it a worm. It spreads on its own. And when you look at the timeline, one thing becomes clear. Shai-Hulud wasn't a one-off. It was an escalating campaign by a persistent learning attacker. On August 27th, the initial Singularity attack took place, which was a precursor for things to come. September 16th, the first Shai-Hulud wave hits with self-propagating capabilities that completely changed the game. And then on November 24th, a second strike lands, timed right before NPM's token revocation deadline. That wasn't luck, that was strategy. From one compromised project to a coordinated campaign in under 3 months. This threat evolved fast, and it wasn't slowing down. Which brings us to that second wave. And it really wasn't just a rerun. The attackers learned from round one, refined their approach, and came back with something far more dangerous and destructive. This side-by-side comparison tells the story. The infection scope grew 5-fold. Their evasion tactics got smarter, switching from a single hard-coded repo name to fully random ones, making tracking way harder. But the scariest upgrade is that last one, a fallback that wipes the user's entire home directory if no secrets are found. That's a huge shift, from stealing data to simply destroying it. Suddenly, this isn't just theft, it's ransomware-level damage. So with all that destructive potential, what did the real-world fallout look like? Well, big. Let's talk numbers. This wasn't a theoretical vulnerability. The worm successfully stole and publicly dumped over 14,000 unique secrets on GitHub. Each one of those is a doorway into a system somewhere, just sitting out there for anyone to exploit. And the impact was huge. Nearly 500 organizations were hit directly. Imagine hundreds of teams scrambling to revoke keys, rotate credentials, and figure out what was compromised. And these weren't fringe projects. Zapier, Postman, ENS domains, tools that millions of developers rely on every day. That's why this felt so immediate. This wasn't something that was happening over there. It was hitting the backbone of everyday software development. But here's the kicker. Those early public reports, they barely scratched the surface. When researchers, including our team at Sonatype, dug deeper, they uncovered a campaign more than 4 times larger. Over 2,100 malicious packages in total. That's the real scale of what we're dealing with. So this leads to a pretty obvious question. With all of these new AI-powered security tools out there, why didn't they stop it? This is the big assumption, right? That AI is a security silver bullet and will solve all of our problems? But when Sonatype researchers ran this malicious Shai-Hulud code through leading generative AI security tools, the results were a complete disaster. Every single tool confidently flagged it as safe. Not a minor mistake, a total failure of the underlying approach. And that failure wasn't an accident. The attackers deliberately engineered the malware to beat AI. They overloaded the context window, removed obvious red flags, buried the real behavior under layers of obfuscation, basically crafting code designed to slip right past AI defenses. So if an AI's educated guess can be that wrong, what's the alternative? Attackers already know how to trick it. We just watch them do it. And without real intelligence and real historical data behind it, AI has no chance of spotting threats that are built to hide in plain sight. You can't stop attacks like this with guesses. You stop them with experience, context, and deep malware insight. And that's exactly why Repository Firewall works. It puts Sonatype's malware intelligence, years of research, millions of data points, and over 950,000 malicious packages identified directly in front of your developers. It blocks malware before it enters your repositories, uses AI plus 60-plus behavioral signals to spot hidden threats, and quarantines anything suspicious. It's the combination of AI and real threat intelligence that gives you actual protection. So we'll leave you with this. The Shai-Hulud campaign proves that attackers are innovating at the speed of open source. They learn, they adapt, and they absolutely will be back. The question isn't whether your tools caught this attack, it's whether your entire security strategy can keep up with the next one.